Section 4, here we are concerned about the amount and the timing of cash flows. Let us look at the structure for a plain vanilla bond, and we've talked about this before. Let's say we have a 3-year bond which makes semi-annual payments. The par value is 1000 and the coupon rate is equal to 10%. What does the cash flow look like? Say this bond is issued at par, which means that we as investors buy the bond at par value, which is 1000. Then, since this is a 3-year semi-annual bond, we will get a coupon payment every 6 months for 3 years. The first payment will be at the end of the first 6-month period, and that payment will be 5%. 5% is half of this annualized coupon rate of 10%. So we'll get 50. The same will happen at the end of every 6-month period. At the end, where the bond matures, we get a final coupon payment of 50 plus the par value of 1000. So this is a plain vanilla bond where the timing of the payments is known and the amount of the cash flow is also known. Payment schedules are similar for a particular type of bond. If we have a 3-year government bond or a 3-year government note, then generally the 3-year government notes will have the same sort of a payment structure. But if we go across different types of bonds, let's say we now consider government bonds and corporate bonds, then chances are that the payment structure will be different for corporate bonds. Corporate bonds often pay based on a reference rate such as LIBOR, and we'll see that in more detail over the next few slides. What we are going to talk about now is principal repayment structures. This is section 4.1. In section 4.2, we will talk about coupon payment structures. Broadly speaking, principal can be returned to investors in different ways. The simplest way is a bullet payment. When this happens, we have a bullet bond. So the plain vanilla bond we just talked about has a bullet payment at the end. Here is an example from the curriculum. If we buy a bond for 1000 and this bond makes a coupon payment of 60, 60, 60, 60, and at the end the money that we get back is 1060, where 1000 is the principal amount or the par amount and 60 is the coupon payment. This is a simple example of a bullet bond. Every period we get the interest payment. No principal is paid during the life of the bond. The principal amount of 1000 is paid at the end. During the life of the bond, the principal amount of 1000 remains outstanding. Another scenario is a fully amortized bond. Here, an equal amount is paid every period. So, in this example, we have a 5-year bond. Each year is one period to make things simple. Now, we are told in this question that the interest rate is 6%, and if the issuer is going to pay us an equal amount every year of 237, then this amount includes a principal repayment as well as an interest payment. And I hope you remember this from quant, but here is what you need to do. In order to come up with this 237 amount, which is effectively an annuity, you plug into your calculator minus 1000 for the present value. So present value is equal to minus 1000. The number of periods is equal to 5. The interest rate is equal to 6%. The future value is 0, and you compute payment. What you should get is this amount. Now the payment of 237 includes an interest component and a principal repayment component. the interest component every period is equal to 6% multiplied by the outstanding principal at the start of the period. At the start of period 1, the principal amount is 1000. 6% of 1000 is 60. The principal repayment then must be 237.40 minus 60, which is this number. The outstanding amount at the end of period 1, which is this point over here, is 1000 minus 177, which is 822.60. We keep doing this for 5 periods. Then at the end of period 5, the principal amount outstanding is 0. So notice what has happened here is we have paid off the principal, or the issuer has paid off the principal over the 5 years. This is called a fully amortized bond. Next, we have a hybrid or an in-between category, which is called a partially amortized bond. What is happening here is that we do have an annuity, but the amount being paid isn't enough to completely pay off the principal. There is a principal amount outstanding at the end, and that amount is relatively high compared to the principal repayments earlier. This relatively large payment at the end is called a balloon payment, because here we are paying off the rest of the principal that is still due. Now let's look at some questions. The structure that requires the largest repayment of principal at maturity. So we've just talked about this. This is a bullet bond where the entire principal amount is paid at the end. A plain vanilla bond has a maturity of 10 years and a coupon rate of 9%. Interest payments are made annually. The market interest rate is assumed to be constant at 9%, and this is something we'll talk about in more detail later. The bond is issued and redeemed at par. The principal repayments the first year is closest to what? Now, in this particular scenario where the coupon rate and the interest rate, the market interest rate are equal, the payments every year are simply equal to the coupon rate, or the payments every year are based on the coupon rate. The principal repayment all happens at the end. For now, you can just take this as a given. We will discuss this in more detail later. So the best answer is A. Relative to a fully amortized bond, the coupon payments of an otherwise similar partially amortized bond are. Now for this question, coupon payments are essentially the interest payments. Notice that we are being asked about a partially amortized bond. With the partially amortized bond, we are paying off less principal, which means that the outstanding principal amount is higher for a partially amortized bond. So the outstanding principal amount is higher. The interest rate is the same. And how do we know that? That fact is contained in this word over here. Otherwise, when the question says otherwise similar, what this really means is that the market interest rate, the rate that we use to determine the interest amount, is the same for both these bonds. So with the partially amortized bond, the outstanding principal is higher, the interest rate is the same, therefore the interest payment is going to be higher than the interest payment for the fully amortized bond. The correct answer therefore is C. Sinking fund arrangement and callable bonds. A sinking fund arrangement specifies the portion of the bond's principal outstanding that must be repaid each year throughout the bond's life. This is a fairly straightforward concept. Let's say that an issuer issues a bond with par value of 1000, and let's say this is a 10-year bond. If the issuer says that he will retire 5% of this amount every year. In other words, the outstanding principal amount will keep coming down every year, then this is a sinking fund arrangement. Since the principal is being repaid, what happens is the credit risk for investors is reduced. The reason is that now the issuer doesn't have to make a large payment at the end. If the issuer has to make this large payment at the end, then the concern for the investor will be whether or not the issuer will be able to make that payment. And that the risk of that happening, the risk of the issuer not being able to make that payment is called credit risk. If the issuer is making these payments along the way, then obviously from an investor perspective, there is less credit risk. But the less credit risk means that there is higher reinvestment risk, because now the investor is getting money back sooner and has to reinvest the money. If interest rates come down, then the investor has to reinvest at a lower rate. A related item is called a call provision, and we'll see this in more detail later, but at this stage, say this very briefly. A call provision gives the issuer the option to repurchase the bond before maturity. When the issuer can do this, the bond is called a callable bond. Now let's look at coupon payment structures. The most simple structure is a fixed periodic coupon, which we have talked about. Here the issuer makes a fixed payment every period. If the period is 6 months and the coupon rate is 10% per year, then every 6 months a payment of 5% of par value is made. Next we come to floating rate notes or floating rate bonds. These are generally also called FRNs. We've talked about these before, but now let's do this formally. Let's say that a company issues a bond and the interest rate is tied to LIBOR. The company says that this is a floating rate note where the coupon rate is LIBOR plus 50 basis points. If this is a 3-year bond, and let's say it is an annual pay bond, so we have 0, 1, 2, 3, the payment made at the end of every period is based on LIBOR at the start of the period plus 50 basis points. If LIBOR here is 5%, then we add the 50 basis points. 50 basis points means 0.5%. The coupon payment at the end of period 1 will be 5.5% of par value. Then let's say that here LIBOR goes up to 6%. The coupon payment here would be 6% plus the 0.5%. So the coupon payment would be 6.5% and so on. A common exam question would be to give you LIBOR over here, and ask you about the coupon payment over here. Remember, the coupon payment is based on the interest rate at the start of the period. Floating rate notes may include a floor or a cap. The idea here is straightforward. Notice that if the interest rate keeps going up, LIBOR in this case, if LIBOR keeps going up, then the payment that the issuer needs to make will also keep going up. So what the issuer might say is that there is a cap of 7%. That means that if LIBOR keeps going up, the maximum that the issuer will pay is 7%. A floor means that this is the minimum amount that the issuer will pay. If LIBOR keeps going down and a floor is set at 4%, this means that no matter how low the interest rates might go, the issuer will pay the investor 4%. Note that a cap is good for the issuer and a floor is good for the investor. We also have something called an inverse floating rate note. This simply means that the coupon payment is some number minus the reference rate. So it's called inverse because if the reference rate goes up, then the overall payment, 10 minus LIBOR in this case, comes down. So there is an inverse relationship between the payment made and the reference rate. A high-level point that we'll make here and then see in more detail later is the impact of a change in interest rate on these two categories of bonds. Notice that if market interest rates go up, then for a fixed period coupon bond, the impact on price is quite substantial. There are two ways to understand why. One is by recognizing the fact that with a fixed coupon bond, we get fixed coupon payments throughout the life of the bond, and the value of the bond is simply the present value of those future payments. If market rates go up, then the present value comes down. On the other hand, with a floating rate note, if interest rates go up, then coupon payments will also go up. If coupon payments are going up, then we are discounting higher numbers at a higher rate. So the value of the bond will not be as impacted. The impact on the floating rate note will not be that substantial. So clearly the impact on the floating rate note of a change in interest rate is going to be less than the impact on a fixed period coupon bond. Next, we talk about a step up coupon bond. This is a bond where the coupon rate increases with time. We could either have an increase based upon a fixed rate, in the sense that initially the coupon rate is 5%, after 3 years the coupon rate becomes 6%, and later the coupon rate becomes 7%. Or we can have a situation where the coupon rate is floating. So initially the coupon rate is LIBOR plus 50 basis points. After 2 years, the coupon rate might become LIBOR plus 100 basis points, and so on. Credit-linked coupon bonds have coupon payments which are linked to the credit rating of the bond. So with these bonds, if the credit rating of the issuer or the bond comes down, then the coupon payment will go up. Payment in kind coupon bonds. With payment in kind coupon bonds, the issuer has the option to pay interest in the form of additional amounts of the bond issue rather than making cash payments. Clearly, this is beneficial for the issuer and potentially risky for the investor. With deferred coupon bonds, the coupon payments are deferred. So if we have a 10-year bond, the issuer might say that we'll not pay any coupon payments for the first 5 years, but then in the next 5 years, the coupon payments will be higher. Here, the benefit to the issuer is that while they are building their factory, for example, they might not have cash flows, but if the issuer anticipates that at this point the factory will be up and running and then there will be high cash flows, then the company can make payments later. From an investor perspective, this is clearly risky because all the payments are pushed out later in the cycle. With index-linked bonds, the coupon payments are linked to some index. One of the most popular examples of an index-linked bond is this bond called Treasury Inflation Protected Security, which is issued in the United States. And here the payments are linked to the CPI, or the Consumer Price Index. Let us look at a detailed example from the curriculum related to different inflation-linked bonds. And I want you to read this first and then I'll summarize the main points. The high-level point in this exhibit is that bonds are being issued and the bonds are inflation-linked. So clearly the benefit or the payment to the investor is somehow going to be related to inflation. The point that this example makes is that there are different ways of making that link. We consider three major types of bonds. First, we have a zero coupon indexed bond. Since this is a zero coupon bond, obviously coupon payments are not being made during the life of the bond. So here the par value, or the amount that needs to be paid at the end, is indexed to inflation. The higher the inflation rate, as indicated by the CPI, the higher the amount that the investor will get at the end. The second category is an interest indexed bond. Here the coupon rate is adjusted based on inflation. And then the third category is a capital indexed bond. Here the principal amount is adjusted based on inflation, but the coupon rate remains the same. But notice that if the par value is adjusted based on inflation and the coupon rate remains the same, when we multiply the coupon rate by the par value, the amount of money that the investor gets is obviously going to be higher. Now let's look at some questions from example 6. Floating rate notes most likely pay annual coupons, quarterly coupons, semi-annual coupons. This is something that I missed earlier, but it's just a fact that you need to know. Floating rate notes most likely pay quarterly coupons. Next point, a zero coupon bond can best be considered a step-up bond, credit-linked bond, deferred coupon bond. You can actually think of a zero coupon bond as an extreme case of a deferred coupon bond because all the interest is being received at the end. There is no coupon in between. The bonds that do not offer protection to the investor against increases in market rates are step-up bonds, floating rate notes, inverse floating rate notes. Actually, the best answer here is inverse floating rate notes, because if the interest rates in the market go up, then the rate paid by this particular bond actually comes down. That's why it's called an inverse floater. So I've mentioned this before. The US Treasury offers Treasury Inflation Protected Securities, or TIPS. The principal of TIPS increases with inflation and decreases with deflation based on changes in the US Consumer Price Index. When TIPS mature, an investor is paid the original principal or inflation adjusted principal, whichever is greater. TIPS pay interest twice a year based on a fixed real coupon rate that is applied to the inflation adjusted principal. So this is actually a very good definition of TIPS, and if you have been paying attention, you will recognize that this is called a capital indexed bond. With an interest indexed bond, the coupon rate changes based on inflation. Here we go back to a hypothetical country. The national government has issued 20-year capital indexed bonds, so that would be like TIPS, linked to the domestic CPI. The economy has been free of inflation until the most recent 6 months, when the CPI increased. Following the increase in inflation, what will happen? The principal amount remains unchanged. That's clearly not true. The coupon rate remains unchanged. That looks right. But the principal amount increases. That also looks right based on what we've seen here. So B is the best answer. Let's take a look at C anyway. The coupon payment remains unchanged, but the principal amount increases. Now this looks a little bit confusing. Notice that the option says payment remains unchanged. The payment actually increases because the payment is based on the coupon rate multiplied by the principal amount. The principal amount goes up, the coupon rate remains the same, so the coupon payment actually goes up. So B is the best answer.